Alrighty, guys, welcome back. Today we are going to be learning about Newton's third law on wheels, this assignment. Particularly for those who are not able to kind of finish this assignment in class, this will kind of give you an idea of what you can do from home, or if you miss some of the instruction in class, here's what you can do. Okay, so first things first, you're going to be making some observations, okay, about the action and reaction of forces as they are done on wheels and on ground, okay? So you could do this yourself. You're going to push up against a wall, standing on a floor, and standing on wheels. You will then have a ball thrown to you and/or throw a ball. You'll do it sitting on a floor, and you'll do it when you're on wheels. Now, if you don't have the little trolley carts that we have, you can use roller blades, roller skates. You could use skateboard, anything you can find that kind of has that wheel option where you can become kind of a free floating object, so to speak. That's the goal. You are recording your observations. Just write out a single sentence that describes kind of what you saw, and that's good enough for that section. This section right here, I need you to diagram what you saw. So everything you see, you wrote here, you're going to diagram down here with arrows and labels. And you're also going to be telling me, was the force equal or unbalanced? And if it was unbalanced, which direction was it traveling? Okay. So obviously when you push on a wall, you have a balanced force. When you are on wheels, ideally you're pushing away from the wall, right? So it's an unbalanced force. The wall is greater than you pushing up against it. Otherwise, the wall would fall over. Throwing a ball as you're standing on the floor, somebody throws a ball at you. If you're on the wheels, or if you're standing on the floor, you're not going to move anywhere. But if you're at the wheels, ideally you're going to be moving a little bit backwards, okay? Because you're a free floating object, okay? This all relates to Newton's second law of motion, okay? And you're going to be using that in your explanation right here, okay? So you're going to describe to me, you use the same amount of force standing on the ground as you did on the wheels. Why were the results different? Okay, right? You're a free floating object. You don't have friction. You don't have static friction or inertia working against you, or at least not as much. Obviously, we can't create a perfect situation because we're not in outer space, but you can describe what a free floating object, such as being on roller skates, and how that might affect things when you have something thrown at you. Couple sentences. You just make sure you answer the question. And in here, this right here is going to be very similar. These two answers are going to be very similar. This one's going to be a little more specific to this experiment. This one's going to be a little more vague, not vague, but generalized for kind of all science, not just this experiment. And if you're working on your own, just come up with your own for this. And they can be very similar, but make sure they're a little bit different. Down here, we're seeing a couple different situations, some application on some scenarios that are that kind of occur in your daily life where it seems like the forces are equal, but they're actually not, based on the results. So if I push an elevator button, I'm greater than that elevator button. So when I push it, it goes in and I don't necessarily go backwards. So although they end balanced, because once you press it in, you're balanced. They're not, right? Because one is greater than the other. Describe that to me here. Do the same thing here. When you try to push a boulder, it doesn't move. Nothing happens, right? It's because it's greater than you. Although it looks balanced, it's not. One's bigger than the other. And then do the last one, which is when a mosquito hits the windshield of a truck, okay? So you get the general idea. That's kind of it. You finish that up and submit it, and that'll do it.